Good evening, everyone. Welcome to the webinar on clean energy and mitigation of negative impacts of transportation on environment, organized by the ITS Turkey as a part of European Mobility Week webinar series. I'd like to introduce myself first. My name is Zafer KORKULU and I work as the head of Energy Transition Department at Energy Market Regulatory Authority, or simply said, the Turkish energy regulator. As Energy Transition Department, we are also in charge of electric vehicle charging regulations. Fossil fuels used in transportation are responsible for a significant part of greenhouse gas emissions, as we all know. Approximately 1/4 of our country's total energy demand, and in parallel, a large part of greenhouse gas emissions originate from the transportation sector. So it's obvious that we need clean fuels and technologies that can be substituted for petroleum products in order to reduce our energy bills, to eliminate the security of supply issues, problems caused by fossil fuels, and to minimize the environmental impacts caused by the transportation. We have three distinguished speakers from three different continents today. Our first speaker is Şebnem Tuğçe PALA. She's joining us from the United States. She's a sustainable transportation professional, working as the Director of Policy and Market Development at Utility API. Professor Ahmet YAZICI from Osman Gazi University, Turkey. He's the head of the Robotics Department and the Director of the Center for Intelligent Systems Application Research at Osman Gazi University. And Joop Spoelstra, I hope I pronounced it correct, from Netherlands. Joop works as Innovation Manager at Technolution. Before we start, I'd like to note that the participants from the audience can anytime type their questions in the chat box area, and I will direct these questions to the panelists after all the presentations are over. Please do not forget to mention to whom you want to ask the question. Let's start with our first speaker, Şebnem. Would you please tell us why sustainable mobility is so important and elaborate more on the key sustainable transportation trends? The floor is yours.
Thank you so much. So should I introduce myself first and then move forward with the presentation? How does it work for you?
It's fine, whatever you like.
Okay, all right. So thank you, everyone. It's so nice to be here. I really appreciate it. So thanks for the invitation once again. It has been an honor for me. So I will start from the very beginning. I will introduce myself first. So this is Şebnem Tuğçe PALA. I'm also originally from Turkey, born and raised in Turkey. So after having worked and lived in Europe for 5 years, I worked for European Investment Bank and United Nations before. I moved to United States in 2016, and I moved to San Francisco Bay Area. As you already know, San Francisco Bay Area is the hub of innovation, technology, and science. So I took some classes from Stanford on science and technology, policy, how AI is creating smarter technologies, how AI is creating smarter technologies, social policy, economic impacts of AI. And I saw the angle there. I decided to combine my background in public policy with technology. So this is how my journey in the field of sustainable transportation kicked off, because I'm very passionate about this field. And since then, I have only worked for high-tech companies, all in the sustainable transportation space, and Utility API is one of them. And in the meantime, 9 months ago, I built my own consulting firm. So I'm only working with high-tech startups in the same space again. And I'm leveraging my background in public policy, market strategy, market research. And if you don't mind, I prepared a presentation for you. So I will start why sustainable transportation is very important, what are the key trends and the challenges we are facing right now. All right, so can you see my screen?
Yes, we can.
Amazing. So what is sustainable transportation? So sustainable transportation can be best described as any type of transport that doesn't rely on the world's natural resources to power it. And we have to highlight that transportation accounts for around 1/5 of global carbon emissions. And the aim of this type of transportation is basically to reduce the negative impacts on environment. It includes both like public transportation, meaning that electric buses, zero emission buses, metro, trains, trams, and private transportation, pedestrians, bikes, scooters, and electric vehicles. And sustainable transportation contributes to a reduction in damaging carbon dioxide emissions, and therefore to a reduction in atmospheric pollution and improved in air quality in cities. And goals of transportation, the main objective is to combat climate change and stop global warming by reducing carbon dioxide levels and improving air quality in urban spaces. And also we aim to minimize the use of the private car, free up parking spaces to become green areas, to encourage and promote public transportation and the use of micromobility. And also, like, we are aiming here prioritizing and non-polluting ways of transportation through clean energy. And top trends in 2022, as you already know, gas car bans make it big here in California. You know, like we have a huge target here. For example, in 2030, we will not have any gas cars here. It will be all electric. So this applies to many European countries as well. And Amazon remakes e-logistics, and ride-hailing looks to electrify. What I'm meaning here, you know, like ride-hailing companies like Uber, Lyft, they will all electrified fleets, and fleets decarbon with low carbon and electric, and slow streets show what's possible. Like what I mean here, well, like with slow streets, with the pandemic, you know, we focus on infrastructure more. So in cities, we have like some private areas, what we call slow streets. So there will be no using of, you know, cars, or, you know, like it will be all electrified, or like it will be all pedestrians, or like it will be all scooters. And the transportation specs, what I'm meaning here, you know, like most of the high-tech companies in the sustainable transportation, they have announced their IPO. So they have become public companies, they merge with other companies, so they are getting big. And also like climate tech hits up, and Biden administration puts end to Trump darkness, and I will focus on that like at later stage. And I have to also mention that public transport moves into crisis, so we have to look for alternatives. And next steps for sustainable transportation, as I mentioned earlier, electrification. And here, like models, price, and incentives, they all play a key role. And other than that, battery autonomy and charging speed, technology, infrastructure, charging points, these are all key elements. And promoting sustainable mobility, you know, what I'm trying to say here, we should raise awareness, like we should have more environmental friendly people, and we should highlight the benefits of sustainable mobility. And local incentives for EV, as you already know, like EVs are very expensive. So we need the support of government here. So we should have local incentives and other clean ways of transportation. And, you know, like tax exemptions, city restrictions for ICE vehicles. I think, like, for example, Paris is doing that greatly. And also like production and distribution on green fuel energies. And regulations. Here, I will specifically focus on US regulations. I'm sure that like you have been tracking and like following this closely, but the Senate has just passed the biggest climate bill in its history, like Inflation Climate Act. So as far as I remember, that means $370 billion. And what it means we are expanding clean energy, and we are lowering carbon emission here, and like there will be a huge boost of adoption of electric vehicles, and we will be reducing cost of clean energy in our homes and lowers industrial emissions. And this will also bring clean energy manufacturing to the United States. And before Inflation Climate Act, we also discussed Biden Harris electric vehicle charging action plan. And that being said, in 2030, as I mentioned earlier, President Biden has united automakers and auto workers to drive American leadership forward on clean cars. And we set a ambitious target here, like 50% of electric vehicle shares in the United States by 2030. And like also bipartisan infrastructure law, we will have like 500K charges across United States in 50 states. And they will be giving us like $5 billion, like they will be giving lots of grants, tax incentives, tax rebates to promote transportation electrification. And other than that, this law also provides $2.5 billion for communities, corridors, like through a competitive grant program that will support innovative approach and ensure that like charger deployment meets Biden's administration priorities, such as supporting rural charging, improving local air quality, and increasing EV charging access in disadvantaged communities. I think here is the key, because like equity is a great component here, because transportation should be everyone. It should be accessible, equitable, sustainable to everyone. So it shouldn't be only for white rich people. Like we should be supporting disadvantaged communities and rural communities where they don't have access to equitable transportation, reasonable or sustainable transportation. That's why we have to highlight it here. And also I want to focus on this one as well. Department of Energy of the United States, and they also want to reduce carbon emission. That's why they are also allocating 96 million funding opportunity to support decarbonizing the domestic transportation sector. And also here again, like this funding will focus on EV charging accessibility, creating cleaner non-road vehicles through electrification, use of alternative fuels, and developing electric drive components and materials to maximize EV efficiency and affordability. And again, this is quite aligning with President Biden's goal to achieve the net zero economy by 2050. I mean, here I specifically talk about regulations because regulation is the backbone of our business. Like technological improvements and regulations are not moving at the same pace. That's why, we have to be watching out the recent updates when it comes to regulations, state legislations, and we have to make sure that like we are complying with their requirements to achieve a net zero economy. Okay, this is all on my end, and if you have any questions and comments, the floor is yours.
Thank you for the excellent presentation, Şebnem. The presentation really gave us a good insight on the American side of the story on the sustainable transportation. So let's continue with our next speaker, Professor Ahmet YAZICI. Professor, there's a rapid development for mobility and energy systems. In addition, the transportation sector demands a high percentage of total energy use. Would you please explain why we need to integrate mobility systems and energy systems, and inform us on the European side, the European roadmaps or strategies for mobility and energy?
Thank you. First of all, I want to thank you, ITS Turkey, that organized this webinar under European Mobility Weeks. Let me share my presentation, okay? Then continue from there. I think you will see my screen. Yeah. Okay. I am from Gazi University and director of Center for Intelligent System Application Research. Actually, as Şebnem Tuğçe PALA mentioned about the sustainability, there's a transformation also in mobility. First of all, I want to make a short picture of the transformation, then I can continue on why do we need to integrate that mobility and energy systems. Okay, as you know, 100 years ago, there was a transformation from horse to cars. Now, the second transformation we are facing with. Actually, the source of this new transformation is also related to power. We are again changing the power of the vehicles, kind of vehicles. Actually, during that time, we are now moving electric vehicles. There are also some other kind of vehicles, but this time there are multiple dimensions actually. We cannot achieve just transformation of source of power. So we need to also integrate automation. Also, we need to use information technologies to realize that one. So this transformation has several other dimensions. Why do we need that? Tuğçe PALA mentioned about that one. There are sustainability and other side of reasons that I do not give in detail. Actually, there is a picture about that alternative fuels, electric vehicles in transportation. As you see, by currently we are at 2020. Okay, we are also still using fossil fuels, but by 2030, the forecast shows that more than almost 50% to use that electrical vehicles. We will live from fossil fuels. Actually, in terms of greenhouse emission and others, we need to make that transformation. Okay, but where we will charge our vehicles? The main question is this one. We will use again the electric grid, but if we again also produce the energy from also fossil fuels for electric grid, we cannot achieve that sustainability goals. So another critical point at this point is battery electrical vehicle is charged from renewable source that support the grid side. So there are some parameters that we need to integrate that electrical vehicles and electric grid side, renewable energy source. Somehow we need to communicate all these. Okay? Actually, integration of the electrical vehicles or as let's say mobility or transportation with energy, which means electric grid, is a requirement actually at this point. So when we take a look integrated future, there are two pie charts you see on the left-hand side. There is the past mobility systems or transportation systems. If you take a look at the part of the pie charts, they are time of use, connectivity, or fuels are there are a few items. But when we look at the future, for example, time of use, where to use, when to charge, or when we take a look at infrastructure, there are wind turbine, solar panels, smart cities, and there are many items there. Also, connectivity is another important thing, so fuels. So, in this context, we need tools for transportation, for mobility to understand the opportunities for renewable energy and energy efficiency, considering the components in the figure. We need to set up new models, including all stakeholders with social preferences. So this is not a technical issue. Also, we need to somehow to model the social part here. When we take a look at in a deeper side, there are different branches you see in the figure. As you know, there is currently vehicle-centric systems, but these will be replaced with a radical or more efficient service-based data-enabled and driverless ecosystem in a combined way. So, in this context, we need to integrate the electric vehicle to electric grid, considering different perspectives. There are two actual main areas. First, grid planning, electric grid planning is an issue. It is more focused on the long-term planning or decisions on charging infrastructure made by charging station owner, investor, and grid connection made by distribution system operators. Another main point here is how can we plan operation of the power systems? It will be a more short time horizon and focus mainly on the coordination of different stakeholders and power equipment in order to ensure reliable and secure operation of distribution power networks. So we need to integrate that mobility and power system in these two contexts. Yeah. So when and where EV charging occurs will be as critical as how much electricity is needed to meet the future electrified transportation demand. Okay. We need to answer these three questions in order to reach our goals in 2030. Actually, there are several issues to be handled during the operations of EV charging management and grid integrations. These are electric power storage, portability and power conversion, improved methodologies for producing and storing electricity and green energy, and etc. So, more novel solution could be also in the table. We need that one. Actually, there are a natural synergy between a shared autonomous vehicle and electrical vehicles technology. So we need to integrate these two. How can we achieve this? Tuğçe PALA mentioned about the US goals and strategies for that one. When you take a look at the European side, there are several roadmaps and organizations which they set up by with regulations. There are different regulations that need to set up these organizations. This one is key digital technologies, and another 2.0. There are several others that I will mention about that first. So when you look at key digital technologies, for example, there are mobility and energy. There are other also sectors that has some interaction during the implementation of these new systems. There are many AI tools, digitalization tools, electronic system and components, all are defined there. When you look at that strategy document for long-term vision or short-term vision, they all mention about how to integrate that electrical vehicles to that electric grid system. How can we achieve that charging management system actually? And in the long term, actually, carbon dioxide neutral mobility is very important there. So 2.0 is another part. I will go faster. You can reach the document from the website. Also in Turkey, there are national IT strategy document and there are action plans that you can find out all this. I also want to make a short introduction to our new European committee project, Horizon KDT project. It's accepted, but it will start possibly end of this year. It is about optimization of electrical vehicle autonomy, because we need that one for 2030. There are 37 partners from Europe, and if you take a look at that figure, the project focus on end-to-end solution. in-vehicle technologies, powertrains, out-vehicle data, ITS, communication with infrastructure, charging infrastructure management, and the critical part, human. You can consider this project with human or without, but currently, as we know, there are some time for autonomy. So this project handles these all technical domains from end to end, from vehicle to electric grid. It also considers social aspects, socio-economic aspect of the problems. Okay, it has many key technologies focused on different areas. The partners developing for that one. There. Actually, it will have 9 demos with various key technologies for each technology domain, including powertrain, air logistic, or mobility as a service, fleet management, how to charging management, and etc. Within that 9 demos, demo 5, we focus on energy efficient planning for last mile delivery. You know, another area. We will show effectiveness of dynamic route planning for electrical vehicles for last mile delivery service, measure economic, social, and environmental effects using a pilot demo application. Actually, we will use that L-type vehicles that produce in Turkey. So what is open to stakeholders or listeners to today these webinars? All OEMs, solution partners, end user organization, or e-commerce or logistics company, or whatever who are interested to this project, contact me, and we can inform all the stakeholders about development of this project. So this is all for my side. If there's any question, I will be happy to answer. Let me stop here. Thank you.
Thank you so much, Professor. We heard the latest projects going on European and the national level. Thank you so much. Let's proceed with our next speaker, Job. I would like to thank Job as he showed a great effort to participate in the webinar. So we can proceed with his presentation. Job, please go ahead.
Indeed, thank you very much. Very happy to be here and to be invited to share with you all, represent the ERTICO. Oh, sorry for this. Yeah, that's the right one. Represent the ERTICO partnership, and also, given that I'm innovation manager for Technolution, we're IT system integrator, develop software and hardware, and I'm responsible for both the mobility efforts and the energy efforts. I love to hear the previous speakers talk about the integration between these two domains, because I really feel a lot of the industry is lacking that integration, and we are moving towards real issues in the two in between. So just to start shortly on ERTICO, of course the strategies. I'm a part of the strategy committee of ERTICO. A lot of the roadmaps that are designed there on behalf of the partnership are very much related to the European Commission policy subjects. So you see on the right hand side a couple of these very high level policy subjects, and on the left side the different roadmaps that have been developed in that regard. Fortunately, I think ERTICO is stepping forward, especially with the clean and eco mobility roadmap, really showing the initial combinations between the original ITS, traffic management, mobility competences towards electric vehicles having to charge, being connected to an electricity grid somewhere, integrating the two and taking steps in that regard. So a lot of projects are popping up. A couple of them are already active, such as Modalis and Elviton, starting up in how to understand how electric vehicles are both driving on the roads and therefore having a need to be coordinated and managed, but also having a battery needed to be charged, needing to adapt their operations on the use that they have. So I think very forward-looking in combining the two aspects. A very promising concept in that regard, and I'm also a part of the ERTICO steering board on the Traffic Management 2.0 innovation platform, which very much promotes in the mobility domain the close collaboration between road operators, mobility providers, OEM end users in collectively together bridging the gap and managing mobility. So for example, public-private collaboration in if there's an incident on a highway, the road administration wants you to take a detour, then all the private navigation providers such as Google and TomTom, they also show this advice in their own individual advice to their own users, and really collaborating in bringing end users in a collective coordinated manner in traffic management. However, as you will see, very much mobility and ITS focus still. So how can public and private entities in the mobility sphere collaborate? And of course, a lot of these vehicles, as we've shown and seen by previous speakers, are increasingly electrified. So you see the first instances in how these two worlds collide. So one example from my company being what we developed in Gothenburg, where there's a zero emission zone in the city center. The municipality on the yellow block is able to sketch geofences in their city center saying this is now a zero emission zone. This geofence can then be exchanged through the city platform towards different OEMs, one of them being Volvo. And if these Volvo hybrid cars, so on the right bottom side, you see a demo car of a hybrid Volvo car, drives towards this geofence, it automatically detects this is a zone in which I can only drive on electrical mode and not anymore on my fossil fuel drivetrain, and therefore either I automatically switch towards electrical mode, or if the battery does not allow, for example, merely show a message to the driver saying, please watch out, you are not allowed to drive in a fossil fuel mode in this zone. So that's, I think, the first very a slow integration of how an electric vehicle can align with ITS applications and mobility applications. However, of course, as I said, these vehicles a lot of times also need to be charged. And that's a point where we often forget in the mobility domain that once in a while, these vehicles need to be plugged in and have to get their energy from the grid. So be this vehicles, buses that we see, we even see the first high heavy duty trucks popping up fully electric. And that proposes a problem. So this is the current map of the Netherlands, my home country, which shows on every red block that you see, if any new entrepreneur wants to get a new connection to the grid, he gets declined. Because the grid management operator says, given everything that's going on in my grid, I cannot allow any more connections to this grid until we figured out how to get this all done. So they're really panicking in all these electrified vehicles and other electrified appliances, all making use of this whole grid. So what is going on there? Well, setting the urban electrification scene, probably a Dutch electrification scene, then again, I figure this will gonna be the reality in much urban zones around the world. We see congestion happening in cables. So this means the energy supply and demand over these cables exceeds the capacity for these cables. And this can mean that they can start smoking, can start burning, and start exploding even. And this has already happened in multiple instances. Not only electrified vehicles are developing, but of course also all kinds of other energy transition modes are changing. So new heat pumps, solar panels, electrical cooking, this is all coming down to this grid. And it's very difficult to predict this because this grid needs 20 to 30 years to be designed, made, then put in the ground. These are very long-term trajectories. And what we see in the prognosis of electric vehicles, solar panels, heat pumps, the reality goes even faster than we have predicted this at the moment. Moreover, there's also a geographic disbalance. So a lot of this energy use is in the cities and a lot of the energy development is in the regions, which is a problem because this all has to flow through the cables. Also, the peaks in which these vehicles have to be charged very much align with the peaks in which the households use their energy. So when you come home from your work, you plug in your car, you put on the light, you start your electrical cooking, you start to heat your house. This is all energy focused. Safety gets an issue in these grids, and there's very much lack of sensing on what's going on in these grids. So we try to help the grid management operators in showing what is the grid actually capable of at the moment and what is going on. So we provide these overviews, and this is a national overview of what assets in the grid are actually on risk at the moment and need further clarification, for example. And this all boils down to, of course, the whole integration between public entities, private entities, not as much in the mobility sphere per se, but more extended towards not only these vehicles have to drive around on the roads and have to be coordinated, but they need to be charged. And if you put in a zero emission zone within the city center, you have to regard this as a mobility measure that you take with an impact on the electricity grid as well, because these vehicles will have to be charged somewhere. So then again, the call from me and from Ertico as well is, given this traffic management 2.0 concept, currently focused on mobility, how can we extend this towards energy integration as well? And that's, I think, a call to action to all the partners involved as well, looking at this concept and extended this with all the different dependencies that are arising. Thank you very much for your time and inviting me to speak here. And I love to be open for any questions that are there. Thank you.
Thank you for your delightful presentation, Job. We clearly see that going EV on transportation have serious impact on the electricity grid, and we really need smart and digital solutions. We have plenty of time for questions, so we can now proceed with the questions from the audience. There's a question for Şebnem. When do you think EV cars will catch the traditional fuel cars in numbers in US, in Europe, and in Turkey?
Yeah, first thing first, I really appreciate these questions. Thank you for this. So actually, in 2030, let alone in California, there will be like 4 million of electric vehicles just in California. And based on the recent statistics, in 2040, 58% of the cars will be electric. So I think this will give us the roughly estimate, you know, like, I don't know whether this will be the number in Turkey, in Europe, or in US, but in the world, like in 2040, 58% of the cars will be electric.
One contribution to this for European side, for actually these are forecast almost over 50%, almost 50.
So the next question is for Job. Can we mitigate the negative effect on the environment by using traffic management methods?
Yeah, I very much love the question, because I really think that the mobility domain in that regard is very much ahead of the energy domain, in the sense that given our history in traffic management, especially dynamic traffic management, we have learned how to combine collective goals that benefit society. So in traffic management terms, improve safety, reduce congestion. These very collective measures, combine them with individual optimum of individual end users. So how to go from A to B in the quickest, safest manner, and how to orchestrate that given traffic lights, given advices on the radio, or what have you. We know that game already. Then again, the energy domain, this is a whole new game of which a grid management operator makes itself almost dependent on how these individual end users will behave. And if in a case that a peak occurs in the grid, the end user will actually switch to lower charging or their electrical vehicles, I think. So I think a lot of the concepts that that we already developed in the ITS world, in how to combine this collective thinking with individual optima, and how to collaborate in a public-private manner, can be translated towards the energy grid as well. And very much so one very concrete example being, if you have a navigation advice, if you want to go from your house to somewhere else, let's try and see if you know you're gonna head to a certain city, maybe let the grid operator know that they expect a vehicle to charge at this point in time in 1 hour, and then also let the navigation provider know you will be charging at this location. There's a certain energy capacity available at that location, and involve that in your travel time advice. So maybe you have the quickest route from A to B, but you are hooked on to a charging point that will take you longer to charge your vehicle. So maybe drive longer towards another destination that will make it charge quicker. So combine these two IT information infrastructures, and I think the thinking that we have in the mobility domain really helps in translating that towards electricity specifically.
Thank you, Job. I have a question for you, Professor. How do you see the future of alternative fuel? How do you consider the future of alternative fuels?
Actually, we have some plans in the world considering sustainability, but there are some crises, Ukraine and some wars. Under normal conditions, if everything goes okay, in the short term or in urban mobility, we more focus on, for example, battery electric vehicle we can use more here. But in long-term destinations, hydrogen is a good, seems to be a good alternative. Or in USA, maybe Tuğçe PALA knows more about. There are mild hybrids when you have some driving habit for long distance. But in Europe and also in Turkey, light class vehicles are more preferred with battery electrical vehicles. So in terms of source of power, currently in urban area, battery electrical vehicles would be preferred more. As you know, in Turkey, we start with just from battery electrical vehicle.
Well, thank you. I have also a question for you, Çiğdem. I want to hear more about your consulting company. What does your consulting company exactly do, and how do you help the startups in this space?
Yeah, sure thing. So I'm helping all these startups with 4 domains. So the first one is market entry, market strategy research. So let's say you want to enter a new market and you want to discover your potential and you want to learn more about your competitors, allies. So I do all the market research and market strategy research for you, and I come up with some recommendations and suggestions for market entry. So this is the first domain. And the second domain is public policy, government relations outreach. So as I mentioned in my presentation, public policy is the backbone of this business. So we have to be tracking all the regulations and legislations, and we have to make sure that we are complying with them. And other than that, we develop B2G, business to government partnerships. So I help these companies crafting their public policy strategy as well. And the third domain is with Biden administration, with Inflation Climate Act, we have lots of funding opportunities. So there are amazing opportunities for electric vehicle charging station companies, for electric vehicle companies. So they are really supporting startups in this domain, and they are giving lots of tax rebates, tax incentives, and funding opportunities. So I write grants for those companies, and I help them adjust and craft their grant strategy as well. And the fourth domain is fundraising strategy. Obviously, like most of these startups are early stage and they are looking to fundraise. So I help them with fundraising strategy as well. So I connect them with the right VCs, because here in the Bay Area, most of the VCs, they have their own verticals. For example, like some of the VCs really love AI, some of them really love healthcare, some of them really love mobility. So I connect them with the right partners, basically. Thank you.
Thank you so much. I guess there is no more questions.
I have a question for the panelists, actually, for Professor and Job, if you don't mind.
Sure.
So I would love to hear their thoughts on the future of sustainable transportation. So are we going to focus on autonomous vehicles more, or like eVTOLs, electric vertical takeoff landing? So do you think that like in the near future, are we going to see autonomous vehicles on the streets, or like are we going to focus on more safety or infrastructure? So I would love to hear their thoughts on that. You know, like this can change from city to city, or like from country to country, but I would really appreciate the like general overview here.
Okay. Actually, for when you consider autonomous vehicle, my first experience with the vehicles was autonomous vehicle in 2007, Dark Urban Challenge in USA. So at that time, we believed that autonomous vehicle will be on the roads by 2020, but we just passed 2020.
That's
You
true.
know, some of them had driving license at 2012 in the USA, but the challenge is Istanbul. Okay, so at some control area. But during that time, when we worked for autonomous vehicle 2004, 6, and 7, we need electrical vehicles at that time. So in the first Grand Challenge in USA, many of the cars are supplied by with gasoline generators. Then in the 2020, we use mild hybrid. Now we more focus on battery electrical vehicles, because we need all power that need for sensors, systems, computers for. So they need each other at some sense. But for the future, when we consider future of the mobility, actually we cannot distinguish or we cannot consider them separately, autonomy and electrical vehicles. Somehow, if you consider car sharing and some other application, we need to combine them, but actually considering the safety, security, and some other issues, we need sometimes. But for now, electrical vehicles, I think they will have more market place compared to autonomy. But the first time autonomous vehicle was on the good place, but now electrical vehicles are good in the market.
Yeah, I agree. And also like there will be downside of autonomous vehicles, safety issues, infrastructure. So there's a long way to go when it comes to autonomous vehicles, in my opinion. And also like this applies to eVTOLs, electric vertical takeoff landing, you know, urban air mobility, and also like regulations are the key. They are the huge challenge here. And what are your thoughts? Yup.
Yeah, I can only agree. Indeed, on the development of autonomous vehicles, it used to be this very futuristic idea. I think at the moment, my personal view would be that possibly there might be a use case where on highways, maybe on a dedicated lane, there might be use of autonomous vehicles. But what I've seen at this point in time in the urban context, I don't see the technology bridging the gap in that regard. I think on the side of electric vehicles, I'm fully convinced that there will be a large breakthrough. I think what we've seen, unfortunately, I'm not there, but the Detroit car conference was, I think, this week, where we saw a couple of very large SUVs. I think my own vehicle can fit into those 3 times, which are indeed now battery electric, and I think that really shows a big change. So for electric vehicles, I definitely think that at least for urbanized areas, that will be the standard. And I think indeed in vertical takeoff, or indeed in urban air mobility, I don't see the use cases and the business cases yet, apart from maybe emergency situations. So there are a couple of use cases where AEDs are being flown around if someone has a heart attack. I figured there's only one way to get it that quick, and that's through the air using a fast drone. But I think that's it. I don't need my pizza delivery to be 30 seconds from the pizza shop to my house. It can take a while using a scooter. It's fine. So on that regard, I don't see the use cases popping up that demand the energy use. I think also the noise that we will have in urban areas if people actually go about or deliver their appliances using drones. I don't see the business case there yet.
Yeah, I agree with you. I agree. And like safety issue, let's say like an autonomous vehicle hits someone, it's a child, who will be responsible for it? And, like whether there are ethical questions, like they are saying that they can even differentiate the difference between black and white people, as well. So yeah, there are ethical questions to it. Thank you so much. Thanks for your responses.
Well, thank you. I suppose there is no more questions. Any last words? Anything to add? Okay, I would like to thank all the speakers and the participants for their contribution. Thank you for joining us, and I wish you have a good night.
Thank you.
Bye.
Have a good one. Bye.
Good night. See you.
Thanks
Bye.
a lot. Bye.
Bye.
Thank you, everyone.
Bye.